Hello and welcome back. Last time we did a lot of stuff and hopefully it wasn't too overwhelming for you. If it was, you might want to take a break to let your brain cool off. In this video, we're going to pick up where we left off last time and talk about that ampersand operator. I'm talking about this guy in front of the variables a and b that we used in the scanf function to take user input. Before anything else, let's do the usual thing by copying the code from the previous lesson, creating a new file, pasting the code, and erasing the stuff from the previous lesson. Now let's declare an int variable and assign it some value. Now let's declare another int variable and assign it the value of the variable a. And now let's declare an int asterisk variable and try to assign it the same variable a. And if we run the code, we will get an error. Basically because int and int asterisk are not the same data types and they're not compatible. But if we add the ampersand symbol in front of the variable a, it will fix the error. What I'm hinting at here is that the asterisk and the ampersand are related, and since we haven't really talked about either in much detail, we're going to kill the two birds right now, so let's get started. Now you might remember that variables represent data stored in computer memory. You might also remember that in order to access data in computer memory, we need to know where in the memory that data is located. The ampersand is an operator whose job is to tell you where in computer memory the data associated with a variable is located. Meaning in our code, a represents the data itself, which is 5, while ampersand a represents the location of the data in computer memory. Alright, so to store an int value, we need an int variable. To store the memory location of an int variable, however, we need an int pointer. And this int asterisk is an int pointer. And just to demonstrate the difference between a regular variable and a pointer, let's print the value of the variable a. Unexpectedly, we get 5, which is the value that we assign to the variable a. Now, if we print the variable that stores the memory location of the variable a, we'll get this long number, which represents the memory address. We also get a warning basically saying that we shouldn't interpret pointers as regular numbers. To get rid of the warning, let's replace %d with %p. P stands for pointer, as you might have realized. And now we get a mix of digits and letters, which is normally how memory addresses are represented. And finally, just to emphasize that the variable c stores the memory location of the variable a, let's print both, like this, to see that both outputs are identical. So again, in C, a data type followed by an asterisk is a pointer. A pointer represents the memory location of the data associated with a variable. And to get the memory location of that data, we can use the ampersand operator. There's a lot more to pointers, but we're going to stop here before it gets absolutely overwhelming. For now, what I want you to remember is that when taking user input, to the scanf function, we need to pass the memory location of the variable that we want to use to store the input. And that's why we had to use the ampersand operator in the previous video. To remind you what we did in the previous video, let's comment out our code by selecting it and pressing Command + / on the Mac, or Control + / on Windows. Alright, what we're going to do is we're going to ask the user to input two numbers. We're going to store the input as floating point numbers, so we need two variables of the type float. And yes, we can declare multiple variables by separating them with a comma as long as they have the same data type. To take user input, we're going to use the scanf function. And yes, we can take two user inputs with just one scanf function call like this. Again, note that we need the ampersand operator in front of the variable names. And finally, we're going to display the result of division of the first number by the second number. Note that when printing the actual data associated with a variable, we do not need the ampersand operator. Alright, so we've talked about pointers. We know that, for example, int is a data type that represents integer numbers. We also know that int asterisk is a data type that represents the memory location of an integer number. And you can have pointers of any data type by adding an asterisk after the data type. In fact, this is not the first time we deal with the asterisk. We have already used char asterisk or char pointer variables to represent text, so let's talk about that now. We know that the data type char is used to represent an individual character. So char asterisk should represent the location of a character in computer memory. Let's see how this works in code. So we declare a char variable and assign it a character literal. Now remember, in C, character literals go inside single quotes. So let's assign the variable x, say the character a. Now let's declare a char pointer and assign it the address of the variable x. And if we print both, expectedly, we will get the character A and its memory address. But we can also use char pointers to represent strings, like this. And we can print the text associated with a string like this. Now, is there a difference between the variable xx and the variable s? Actually, not really, meaning we can print the variable xx as a string, in which case we get the same character A, and we can print the variable s as a pointer, in which case we get a memory address. So what the heck is going on here? How come a char pointer can represent both a memory address and a string? Well, this has something to do with the way strings are stored in computer memory, which we're going to talk about in the next video. Before you close this one though, as usual, to test your grasp on the material covered in this lesson, you can take a quiz that you can find in our Patreon page. The link is in the description. If you have questions or need help with the material in general, you can schedule a one-on-one meeting with me. The link is also in the description. And of course, don't forget to like and subscribe if you haven't yet, and turn on the bell not to miss the next video. And I'll see you then. Bye.